Today our team, which consists of Benjamin from K4, Rainius from K5, Lim from K6 and myself, Avinash from K7, will be presenting about our statistics project. The title of this project is The Evaluation of Post-thaw Ovine Sperm Motility in Different Temperatures following two thawing protocols.
How this project works is, we investigate different thawing protocols and conditions to thaw black belly sheep semen in order to achieve the most average sperm motility. This experiment has immense relevance in the biogenetics field as it helps us determine the ideal thawing conditions for sheep semen.
The first objective of this experiment is to investigate the post-thaw motility of cryopreserved Barbados black belly sheep semen thawed using 37 Celsius and 4 Celsius water baths. The second objective is to investigate the sequential post-thaw motility of cryopreserved Barbados black belly sheep semen under 37 Celsius and room temperature.
Here is the data for our project. Three things are being recorded here. The first being the 4 conditions for the thawing. 37 here refers to the temperature in which the sperm is thawed. Room means it is brought to room temperature to thaw for half an hour. 37 here means it is brought to a room with 37 Celsius, which is at 37 Celsius to thaw. Ice, on the other hand, means it is thawed at 4 Celsius and it is then brought to room and 37 Celsius temperatures to thaw for half an hour. The second metric here is the time, and we can see that the motility of the sperm is being recorded for every 3 minutes in the span of half an hour. So here we can see the initial motility is recorded at 0 minutes and it is updated every 3 minutes until half an hour is reached. The third metric here is the motility of the sperm. Motility basically means the activeness of the sperm cells, and it is recorded in percentages here, 100% being the most active and completely healthy sperm. As we can clearly see from the chart, we have quantitative data and 4 samples. Therefore, according to this mind map, what we should do is a one-way analysis of variance, and that will be our statistical method in order to determine which of the samples is the most efficient. We believe that one of the samples will provide significantly high motility for the sheep sperm, and therefore we will make a prediction and we will test that prediction in our one-way analysis of variance.
Now we will be doing our one-way ANOVA. There are 5 steps to completing the one-way ANOVA, and in the end, we will be able to form a conclusion regarding our data sets and be able to tell if there is a difference between the means or there isn't. Step 1 of ANOVA is stating the hypotheses. In ANOVA, we have 2 hypotheses, which are the null hypothesis, stating that all means of each group are the same, and the alternative hypothesis, stating that there is at least one difference between the means. At the end of ANOVA, we will be able to either reject or won't be able to reject the null hypothesis. Step 2 is finding the degrees of freedom. There are 3 degrees of freedom, which are the degrees of freedom between, degrees of freedom within, and degrees of freedom total. To find the degrees of freedom between, we have to subtract 1 from the total number of groups, which is 4, giving us a value of 3. For degrees of freedom within, we have to subtract the number of groups from the total number of data, giving us a degrees of freedom within of 40. And then for the degrees of freedom total, we will be adding degrees of freedom between to the degrees of freedom within, giving us a value of 43. And from these degrees of freedom, we can find that our F critical value from the table is 2.84. Moving on to step 3. For step 3 of the one-way ANOVA, there are 3 parts. The first part is finding the means of each group and the grand mean. The mean of our first group is 82.72. The second group is 91.8122. The third group is 73.6364. The fourth group is 65. And lastly, the grand mean is 78.2955. For the second part of step 3, we will be finding the sum of squares. There are three sum of squares, which are the sum of squares total, the sum of squares between, and the sum of squares within. For sum of squares total, we will be finding the sum of each data subtracted by the grand mean, which we found just now, squared. And this will give us a value of 15,997.1591. For the sum of squares within, we will be adding each data subtracted by the mean of its own group to the power of 2. And for this, we will get a value of 11,586.3636. Lastly, for finding the sum of squares between, we will be subtracting the sum of squares within from the sum of squares total, giving us a value of 4,410.7955. For the next part, we'll be finding the mean squares of our data set. So there are two mean squares, which are the mean squares between and the mean squares within. For mean squares within, we will be dividing the sum of squares between with the degrees of freedom between, giving us a value of 1470.2652. For mean squares within, we will be dividing the sum of squares within with the degrees of freedom within, giving us a value of 289.6591. So now, we will be finding our f value. To find our f value, we will divide the mean squares between with the mean squares within, giving us a value of 5.0758. Therefore, since our f value is larger than our f critical value, which we found in the first step of our ANOVA, we have succeeded to enter the critical region for the rejection of the null hypothesis. So now is the conclusion. So we can conclude that there is at least one significant difference among the data, which means that there is a difference in the post-thaw sperm motility based on the different thawing protocols and different storage temperatures. Due to this, we can totally reject the null hypothesis, thus stating that there are at least one difference of means between the groups.